What we're looking at here, we're talking about the J71's variable inlet stator system, or variable entrance guide vane system, as Allison called it. Speaking of that, a few disclaimers. I've used several primary source documents to gather all the information about this system. Some of it's from Allison, who manufactured the engine, some of it's from the United States Air Force, and some of it's from the United States Navy. So essentially, all this means is that the nomenclature is going to be different from entity to entity. I'm going to try to standardize that a little bit, but some of these parts are the same, but the different entities call them different things. Now, to start with, the J71 is this particular system is very similar to the J73's variable inlet guide vane system, both in construction and also in operation. And we'll talk about operation later. So both of these engines, the J73 and the J71, can trace their roots back to the General Electric designed J35. Now, the J35 was designed by GE, but it was manufactured by GE and Allison. In April of 1949, the J35-23 was redesignated the J71, and that first ran in April of 1950. While with GE, the J35 was developed into the J47, and then in mid-1949, the J47 GE-21 was redesignated the J73, and that was first tested in mid-1950. So, best I can tell, the J71 came a little bit before in terms of design start date and first run. But, other than the best I can find for the GE portion is they say mid-49 and mid-50, so I'm not exactly sure which month. But given the way the military designates engines, it looks like the application for the J71 did come first because chronologically it's earlier. This isn't always true, though, J52 being a good example. In any case, let's get started talking about the J71 system. So over here, this is basically the hydraulic system, and these vanes were actuated via the hydraulic system. So it starts with this guide vane selector. Well, actually, what it starts with is, let's go to another picture here. Don't need that. And we do need this one. All right, so item 7 right here, this component right here is called our speed sensing control. It's centrifugal flyweights, just like in the J73 and a lot of engines out of the 50s and the 60s. We'll talk about those switches during the operation of the system, but essentially this is what tells our guide vane selector valve, or we'll just call it our pilot valve, to actuate our guide vane actuators, and there's 3 of those guide vane actuators. So once we've established that, let's go over here real quick. We'll talk about the other components in the system. So this is the actuator. Again, there's 3 of them. There's a rod end on it, and at one end of the rod end is the actuator. At the other end of the rod end is this crank, or bell crank, however you want to call it, which is splined at the far end to this splined shaft here. This splined shaft fits into the outer support case right here, as you can see. You have your outer case, got all your vanes in here, and then you got right here your inner support. And if we come over here and look at that, so it's the same thing, outer support, inner support. So this splined shaft is going to go through your case like this, and it's going to fit right into this splined end of our pilot vane. And there's 3 pilot vanes, one for each of the actuators. Now the pilot vane is splined on one end. It's going to connect to this lever. We call it a pilot lever. That's going to go through this inner support. And you see there's 3 holes here, 1, 2, and 3. Those are for your 3 pilot valves, or pilot vanes, sorry. And together they rotate the rest of the ring, which is where all your follower vanes and the follower levers are attached to, so such that when the pilot vanes move, they're going to cause this drive ring to rotate and move all the other vanes with it. They've got bearings just like in the J73 system. And also, similar to the J73 system, it's got all of the mechanical portions of this are internal of the engine. They're not external like you see in modern systems. And I'll probably make a short video about kind of the evolution of systems. And in fact, something interesting to point out, the J73 was replaced by the J79. And the J79, as far as I'm aware, is going to be the first engine where we start to see all the actuating mechanisms for this variable stator vanes on the outside of the case. They're no longer inside the case, they're now outside the case. And also on the J79, which we'll talk about, it's got variable stator vanes, not just inlet guide vanes. So anyway, that's how this system is constructed and how it operates. Let's see if I have, so here's a picture of your pilot valve, or the guide vane selector valve. So as you've got electrical connection here, then you've got 2 hydraulic connections there, and then 2 up here, and these all go out to your actuators. So that's very briefly how the system, and I can also show, let me talk about this real quick. This is the hydraulic system. I've kind of colored in red all the conduits for the fluid. So we've got our tank here, or hydraulic reservoir. Get your pump. So what leaves your pump and your relief valve also, because this is a two-way system. You've got fluid leaving your pumps going up here. Now what concerns us is right here. This is our pilot valve, and this controls fluid to and from your guide vane actuators. You see we just put fluid either on this side to extend them or on this side to close them. So pretty simple system, but it's also got your inlet screens is hydraulically actuated through this system, and then we've got our the jet nozzle, or they weren't called turkey feathers. I think this was an iris type system, but it's also hydraulically actuated via the system. Oh, something else that's really interesting. I haven't seen this before in a jet engine. Our heat exchanger here. Usually you have like fuel to oil, air to air oil coolers I've seen. Bunch of different mediums for this, but in this one there's actually 3 fluids. You've got fuel from your fuel control coming through here. It's going to come in this side, it's going to leave this side, and then it's got our drip drain valve right here. You've got lubricating oil coming in this side and leaving this side, but you've also got on this side hydraulic fluid going in and going out. So this particular heat exchanger is going to be exchanging heat through 3 different mediums: fuel, oil, and hydraulic fluid. I have not seen that before, and I'd be really interested in seeing kind of how that system works, because looks like it's going to get, the fuel is going to get heated by the hydraulic fluid first and then by the lubricating oil. I mean, that's just what it looks like here. I'm not sure exactly, but in any case, it's a subject of another video. This is a quick overview of the construction of the J71's inlet guide vane system. All right, so here we have this little thing I put together in PowerPoint. Essentially, this is just kind of show, that lineage from the J35 down to the J71 and the J73. So GE started design work, originally called the TG180, later redesignated J35 and 43. First run April of 1944. From that, GE built 2 prototypes. From that, Allison built the Dash 3, and Chevrolet also manufactured some similar engines called the Dash 3s. Now, in 1946, GE handed over all development and production to Allison, which is why Allison did so much with this engine. You see very early models here. Went to some later high power, I say high power, 5,000 to 5,600 shaft or pounds of thrust on these 2 engines here. They got to the Dash 23, and that was later designated the J71. We've kind of talked about what happened there, why it was changed. GE, they did a couple of engines for the XP84 and 84A. From this, they developed the J47 down to the Dash 21, which again was redesignated J73. Now, a lot of the reasons that these engines were redesignated from earlier models has primarily to do with the fact to receive funding. I guess DoD. This is right after World War II. DoD is slimming down quite a bit. Reducing the amount of money they're spending, and instead of in their minds spending more money on these older engines, they called them the manufacturers would call them something different and get a new source of funding. The same thing happened with the B-29 in terms of the B-50. The B-50 is a B-29 with there are differences, but predominantly the new R-4360 engines. But yeah, you change the designation and you get more money. It seems to kind of be the case around this time. All right, so from there, we're going to talk about how the system actually operated, how it functioned. So we spoke about this speed sensing control in the last portion of this, and this is kind of where the system, more or less, this is what operates the system. So before engines start, your 28 volt DC bus is energized, and what that's going to do is it's going to energize your pilot valve right here. And it's going to allow all those guide vane actuators to fully close your guide vanes. Once the engine starts spooling up, this speed sensing control has a switch in there. They called it the 4500 RPM switch. And on this particular engine, 4500, well, the RPM range was 4,252 to 4,500 RPM, which in terms of percent is 69.4 to 73.4%. But we're just going to refer to it as the 4500 RPM switch. So once the engine's spooling up, hits 4,500 RPM, this speed sensing control is going to cause this guide vane selector valve, this pilot valve, to change the position of these guide vanes to fully open. And again, that's at that 4,500% or 4,500 RPM. Now, once you get past that threshold, the engine or the guide vanes are going to stay open, full open, until the engine decelerates below that threshold. So 69.4 to 73.4% RPM. Within that range, wherever the setting is, once you fall below that, that 4,500 RPM switch is going to open, and it's going to allow this selector valve to take these guide vane actuators and move those guide vanes back to full closed. So very similar to the early configuration of the J73 system, this one is modal in operation. So the vanes are positioned either fully closed or fully open. But in contrast to the J73, this is done in terms of engine RPM, not compressor inlet temperature. So that's the big difference. But otherwise, these two systems, they operate very similar, and they're constructed in much the same way.